Hello and welcome to another video on factorising, and in this video we're going to take a look at factorising expressions that involve indices. Now I've got lots of videos on factorising and expanding, and I've put them all together into a playlist which I've put in the video description, so if you'd like to have a look at that playlist to give yourself some more practice on this topic, then please feel free to do that. So I've got two examples that I'm going to go through with you on how to do this, and then I'm going to give you loads of questions to give yourself some practice. So the first one, we're going to factorise 2x squared plus 10x. Now the first thing I like to do is to find the highest common factor. So what is the highest common factor of these two terms? And I always like to separate the numbers from the letters. So first of all, let's think about the highest common factor of 2 and 10. Well, that's just going to be 2. And now what's the highest common factor of x squared and x? Well, that's just going to be x. We can divide both of these terms by x. Okay, now we've got the highest common factor. What we do is we take out that highest common factor from our expression, and let's put in some brackets. And now we divide each term by the highest common factor. So I'm going to divide 2x squared by, I was going to put x then, but no, by 2x. And then we do the same with the second term. So we divide this also by 2x. So what is 2x squared divided by 2x? Well, the 2's cancel out. So x squared divided by x is just going to be x. And then we're going to add on 10x divided by 2x. This time the x's cancel out. And all we're left with is 10 divided by 2, which is 5. So this is our final answer. 2x outside our brackets and then x plus 5 inside our brackets. And you can check this. So the good thing about factorising and expanding is they work in reverse. So you can always check your answer by expanding the brackets. I'm not going to do that, but if you did expand the brackets, you will be left with your original expression. And now let's go through the second example. So we're going to factorise 6x to the power 5 minus 8x squared y. So just like before, we're going to find the highest common factor first. And again, I'm going to focus on the numbers first. So the highest common factor of 6 and 8 is going to be 2. Now let's think about the x terms. So the highest common factor of x to the power 5 and x squared. Well, that's just going to be x squared. It's always the lowest degree x term. And now let's think about the y terms. But notice we don't have a y term over here. So we can't factor out any y terms. So our highest common factor is 2x squared. So I'm going to take that 2x squared outside of my brackets, and I'm going to divide each term by 2x squared. So I'm going to divide the first term by 2x squared, and I'm going to divide the second term by 2x squared. So what does that give us? Well, the first term, 6 divided by 2, well, that's just 3. And now we've got x to the power 5 divided by x squared. Now, if you're a bit unsure on how to do this, this is all about your laws of indices. And I do have a separate video dedicated to laws of indices, so please make sure you check that out if you're a bit unsure on this topic. But let's just go through our laws of indices for division. So we've got x to the power 5. Well, that's just going to be x times x times x times x times x. Three, two, one, action. And I've just changed the colour of my multiplication just because x and times look quite similar. And then we're going to divide all of that. So this is x to the power 5. And we're going to divide that by x squared. So that's just going to be x times x. So you can see that some of these cancel out quite nicely. So x divided by x, those two cancel out. These two also cancel out, and look what we're left with in the numerator. We're just left with x times x times x, which is just x cubed. So x to the power 5 divided by x squared is x cubed, but there's a much easier way of doing that, and that is just noticing these powers here. When we divide things with the same base, all we do is we subtract our indices. So all we're doing is 5 minus 2, which gives us 3. So we know that x to the power 5 divided by x squared is x to the power 3, or x cubed. And then we're going to subtract, and now we'll look at this term. So 8 divided by 2 is 4. X squared divided by x squared, well, those two terms just cancel out. That's just 1. And all we're left with is y. So this is our final answer. And again, if you wanted to, you can expand the brackets just to check your answer, and you should be left with your original expression. Okay, so now I've gone through a couple of worked examples, and I'm going to give you a bunch of questions to have a go at. Okay, I've got 9 questions for you to have a go at, so pause the video and see if you can factorise these 9 expressions. Okay, I'm assuming you've paused the video, so let's go through the answers. So question 1, we've got x squared plus 7x. So first of all, let's work out what the highest common factor is. Now, we don't have any numbers in this term, so we can't factor out any numbers, but we do have an x in both terms. So our highest common factor is just x. So what I'm going to do is divide both terms by x. So we need to take out the x from our expression, put our brackets in. X squared divided by x, well, that's just x. And then we're going to add on 7x divided by x. The x's cancel out, so we're just left with 7. So this is our answer here. X in brackets, x plus 7. Okay, the next question. Question 2. So our highest common factor. Well, let's first of all think about the numbers. Highest common factor of 4 and 10 is just 2. And then the highest common factor of w squared and w, well, that's just w. So we've got 2w that we're going to factor out. So let's divide both terms by 2w. So we're going to take out the 2w from our expression. And then in our brackets, 4 divided by 2 is 2. W squared divided by w is w. And then our second term, we're going to add on 10w divided by 2w. The w's cancel out, and we're just left with 5. Okay, question number 3. So we're going to find the highest common factor first. And then notice again, these two terms, neither of them have numbers. So we're just going to focus on the letters. So we've got x squared and x. So we can factor out an x. And then this term doesn't have a y. So we can't factor out any y's. So we've just got x that we can factor out. So if I divide both terms by x, x outside the brackets, inside our brackets, x squared divided by x is x. And then xy divided by x, the x's cancel out, so we're just left with y. Okay, question number 4. So the highest common factor of 6 and 4, well, that's going to be 2. And then the highest common factor of c squared and c, well, that's just going to be c. And we don't have any d's in the first term, so we can't factor out a d. So we're going to factor out a 2c. So let's divide both terms by 2c. So 2c goes outside the brackets. And then inside the brackets, 6 divided by 2 is 3. C squared divided by c is just c. And then we're going to subtract. 4 divided by 2 is 2. The c's will cancel out, and all we're left with is d. Okay, question number 5. So our highest common factor of these two terms. Well, the numbers, the highest common factor of 8 and 12 is 4. And now the letters, the highest common factor of c cubed and c, well, that's just going to be c. We can only factor out one c. So let's divide both terms by our highest common factor, which is 4c. So 4c comes outside the brackets. Then inside our brackets, 8 divided by 4 is 2. C cubed divided by c is c squared, and this is using our laws of indices. You could think about this c as just being c to the power 1. So remember, when we divide numbers with the same base, we subtract our indices. So it's going to be 3 minus 1, which is 2. And then we're going to add on. 12 divided by 4 is 3, and the c's will cancel out. So this is just our final answer. Okay, question number 6. So the highest common factor of 8 and 10 is going to be 2. The highest common factor of a and a, well, that's just going to be a. And the highest common factor of b squared and b is b. So we can factor out a 2ab this time. So divide both terms by 2ab. So 2ab comes outside the brackets. 8 divided by 2 is 4. The a's cancel out, and b squared divided by b is just b. And then we're going to subtract. 10 divided by 2 is 5. The a's cancel out, and also the b's cancel out. So all we're putting on the right hand side is just 5. So actually let's just let's just delete that bracket and make it a bit closer. So this here is our final answer. Okay, now we've done 6 of them, and notice for all 6 I've used exactly the same method. So step 1, find the highest common factor. Step 2, divide both terms by the highest common factor. So nice process there for each of these. So let's move on to question number 7. So what is the highest common factor of these two terms? And again, let's think about the numbers first. The highest common factor of 32 and 24, I think that's going to be 8. If I'm correct. Yep, you can't factor out anything greater than 8. And then the y terms, we've got y cubed and y squared. So we can factor out a y squared from both terms. So let's divide both terms by 8y squared. Divide by 8y squared. So let's take that 8y squared outside of our brackets. And then inside our brackets, 32 divided by 8 is 4. Y cubed divided by y squared, well, that's just going to be y. And then we're going to add. 24 divided by 8 is 3. And the y squareds also cancel out. So this is our final answer. Question number 8. So the highest common factor of 4 and 12, well, that's going to be 4. And then the highest common factor of a to the power 5 and a cubed, well, that's just going to be a cubed. Oh, let me make that 3 a bit clearer. So remember, it's always the lowest degree term. In this case, it's a cubed. Okay, so we can divide by 4a cubed over here, and we can divide by 4a cubed over here. So the 4a cubed comes outside of our brackets. 4 divided by 4, those cancel. A cubed divided by a to the power 5 divided by a cubed is a squared, because 5 minus 3 is 2. And then 12 divided by 4 is 3. And the a cubed terms this time cancel out. So this is our final answer. And finally, we've got a bit of a long one here. We've got 3 terms this time instead of 2 terms in all of the other ones. But the process is the same. So we need to work out the highest common factor of all of these terms. So let's think about the numbers. What's the highest common factor of 27, 12, and 9? Well, that's going to be 3. All 3 of these terms are divisible by 3. Now let's think about the g terms. We've got g to the power 4, g, and g squared. So it's always the lowest degree term, and that is just g. So we can only factor out a g. And then the h's, we've got h, h squared, and h. So again, we can only factor out a h. So our highest common factor is 3gh. So I'm going to divide every term by 3gh. So exactly the same as before. So we take the 3gh outside of our brackets. Let's make it a bit bigger. So the first term, 27 divided by 3 is 9. G to the power 4 divided by g is, actually let me make that 9 a bit clearer. It looks a bit like an A. So g to the power 4 divided by g is g cubed. H divided by h, those two terms cancel out. So that's the first term done. Then the second term, 12 divided by 3 is 4. The g's cancel out this time. And we're left with h squared divided by h, which is just h. And then the last term, 9 divided by 3 is 3. G squared divided by g is just g. And the h's cancel out. So this here is our final answer. So it's quite a long video today. Hopefully this was useful. Hopefully you got a lot of practice with factorising expressions. I have, if you're looking at going a step further onto factorising quadratic equations, I've already done those videos. So please check out my playlist for all things factorising and expanding. So thanks again for watching, and hopefully I'll see you for the next video. Take care.